guys, welcome back. We are talking today about combining like terms, and this is part two, and it kind of ties in with what we did on the last lesson with rules of exponents. So first things first, the example number one says, are these things all like terms? First thing that you want to do is you have to be able to compare the same thing. Now keep in mind, if we back up here and we do 3 times 7, that gives us 21, right? 7 times 3, that also gives us 21. Remember, we're allowed to multiply things in any order, and that is called any gosh darn order, our commutative property, okay? So our commutative property says that. So when we go to compare something or like terms, we gotta make sure we're comparing the same thing. So in this case, I always like to group my terms together, but I like to put them in alphabetical order within those terms. This one, already in alphabetical order, no problem. Then we take a look at this guy, so we have this one, and then instead of this, I'm going to put it in alphabetical order. So I'm going to say 3xy squared, and I'm just going to cross that out, and I'm going to say, okay, here's our other term. Maybe box those so we can see them nicely. And then we come over here, and we've got to simplify this a bit. Remember, each one of these has an exponent of 1. So I have 7x to the 1 power, but then there's 2 y's, and if you remember from the last lesson, we can combine those and get y squared. And so I've put that in alphabetical order. Now looking at this, 2xy squared, 3xy squared, 7xy squared. Those are absolutely like terms. Now it doesn't ask you to do this, but if you wanted to combine those, you would get 2 plus 3 plus 7 would give you 12. So we would have 12xy squared. Nothing happens to our little tag that is attached to those numbers. That stays exactly the same. We only mess with those numbers. So let's take a look at this guy. There are 1, 2, 3, 4, 5, 6, 7 terms in this chunk here, this expression. I want to make sure first that I am comparing all the same things, and that within each of those chunks, they're in alphabetical order. I can already see that this one's not in alphabetical order, so I'm going to cross that out and write 3xy. So now we're comparing the same things. I like to put the ones with the most variables first. So I see that I have 2xy, 3xy. Notice too, let me do this. I'm going to underline that operation that comes before it, because that's important. That tells you if it's a positive or a negative. So be really careful about that. 2 and 3, that gives me 5xy. Here's the satisfying part. Once you've got that, just cross them off so they're out of your way. Now we're going to do our 4x and our 6x. I don't see any other x's there, so those combined give us 10x. Cross off, cross off. Now we're going to do our 3, our 4, and our 2. Notice I'm double underlining some things, triple underlining the others. That's because I'm identifying which ones are like terms. It's just kind of helpful thing to do. Okay, so then we've got 3 and 4 is 7, 8, 9, so plus 9. And this is your final answer. We cannot combine anything else here because they aren't like terms. Okay, so again, we want to make sure things are in alphabetical order and they're nice and simplified. With this one here, I see this 2xx. Remember, it's 1 and 1. This is 2x squared, so we're going to cross that off. Okay, so everything else looks pretty good. Let's start with our x squareds. We have 3x squared and 2x squared. That gives us 5x squared. Let's cross those off and move them out of our way. Now we have 4x and 3x. That's going to be plus 7x. And again, I probably should have done that just so you can see. I take note of that operation that comes before there. Now we have 4 and 7. That gives us 11, positive 11. So we're going to add 11 to it. This is our final answer. Final answer. All right, folks, the practice problems are on page 318. Go ahead, pause the video, do those, and come on back. Make sure you've got them. All right, first things first, we want to put these nice and in order. So this is going to be 3xy squared plus 2 x squared y minus 6xy squared plus 3xy squared. So we actually have two different things here. We have xy squared and we have x squared y. So like this guy right here, that's going to group together with this one here. Okay, this one is going to group together with this guy. So let's go ahead and combine those. We have 3xy squared and negative 6xy squared. Keep in mind, you want to underline that operation that comes beforehand. That's negative 3xy squared. Now we have 2xy squared, or I'm sorry, x squared y and 3x. Oh, wait, I made a mistake there, guys. This is the only x squared y. What am I doing? What in the world am I doing? I didn't even see that. Okay, so with that said, let's do this. So we know that that was -3, right? These two things. Now, if we were to combine this, -3 and +3, that gives us 0, right? So this and this all cancel out. And then we have just this guy here, 2x squared y. That is the sole remaining survivor there. Okay, let's take a look at the next one, and I'll try not to mess up on this one. All right, this is going to be, there's 3 x's there, so we're going to say x to the third. Cross that out. And then this one's not in order, so we're going to bring down that minus sign, and we're going to say 3xy. Cross that out. All right, so let's start with our highest exponent. Don't forget there is a 1 in front of here. So we have a 1 here, and we have 4 here. So that's going to be 5x to the third. So this goes away, this goes away. Now we have 3x squared y. I don't see any other x squared y's, so I'm just going to bring that down. Plus 3x squared y. Now we have 2xy minus 3xy. So that's going to be minus 1xy. Now, generally we don't put the 1 there, but it's okay if you do. Keep in mind, in the back of the book, when you look at the answers, they're going to be a little bit different every time, and that's okay. You just got to realize why they're different. Maybe you have a 1 here and the back of the book doesn't, or maybe the back of the book put this chunk first and this one second, but you know we can add things in any order. Okay, let's organize these and then we'll combine those. So this is going to be x y to the third, because there's 2 here, 1 here, plus x squared y squared minus 5x to the third y. It looks here like none of these can be combined because these guys, here's each one of our chunks, right? There's a chunk here, or terms, I should call it something appropriate. Each one of these is a term, and terms are broken up by addition and subtraction, and none of those match. So this is your final answer. You just leave it like it is. Xy to the third plus x squared y squared minus 5x third y. That is your answer, folks. If you have any questions at all, let me know. Otherwise, we'll see you next time. Thank you.